Hello everybody and welcome back to the CH&FR Railroad Goes Digital. Today we're going to take a look at the software side of programming Arduino. I'm going to do a live example of programming using a turnout control panel built with Berrett Hill Touch Toggles and your standard RC servo motors. So there will be a companion video to this covering the hardware setup and wiring, so look forward to that coming out soon. But in the meantime, let's fire up our PCs and get started programming. Before we get started with programming, I wanted to show you the Arduino website and some places where you can get reference information and learn. The website address is arduino.cc, and this is their homepage. There's a couple of places you'll want to look. You can go here to shop for Arduinos and accessories. You can go here for some training. We'll pop into this. You've got some getting started instructions for both the on your computer version or the online web editor, and how to install that, and some tutorials and things you can access from here, and some general information. There's information on specific boards over here to the right. And we have the documentation section. Under this we have some tutorials, which I encourage you to look through, and they'll help you understand programming and using an Arduino in general. Then under the reference section, you'll find some useful information. We have, it'll first come down here to functions in the language subsection. These are some of the built-in functions that you can use in your programming. We'll be using the digital read to access our pins and read the inputs, and the pin mode to set things up. We'll see that in a bit. We'll also be using the delay function in the time group here, but you can look through all of these and see what's interesting. Down here under variables, we'll be using the high and low constants and the input constant. This is defines what type of pin a specific pin is. We'll see that. This is used in the pin mode function above. I'll be using true and false, and we'll be using probably the bool or boolean data type and the integer and possibly the string types, and we'll see. And then under structure, these are the code structures, and it'll be very good to look at those. We'll be using the loop and setup functions, and we'll be using the if and the else, and we'll be using the for loop. So you want to look at those under control structures. We'll be using defines. We'll be using includes. We'll be using comments, semicolons, and curly braces. All of this stuff. We'll be using some of the arithmetic operators and some of the comparison operators. Probably not be using pointer access or bitwise stuff, or might use the compound operators, probably the increment, and maybe some of the booleans. Anyway, this is sort of about the structure of the language and how to do things. You'll see more when we actually program. Over here, we'll look under the libraries section. These are some of the libraries you can bring in. There are a lot of them. There's one specific we'll be using is the servo library. And so if we look at that, you can see this is what's going to control our servos. Down here under usage, it'll kind of explain how to use them. There's a couple of examples you can look at. We'll be using specifically the attach method to connect the servo controller to a specific pin, and we'll be using the write method to move the servo and change its position. So there's plenty of interesting stuff here. There's a whole forum community you can get involved in. A lot of interesting blog entries, and but this entire documentation section is well worth some study. So having said that, let's get started with some programming. Okay, I want to try something a little bit different. I want to show you how to write the code that goes into the Arduino for the touch toggle servo control. This is going to be as simple as I can make it, and not necessarily the best or even the most efficient way to write code, but I want to make it clear for people who don't really know code structures or things like that. So I'm going to make this as simple as possible. So in the Arduino program, when you launch it, it'll open with a brand new file, which will look something like this. And usually it'll give it some kind of generic name based on the date or whatever. And I've already opened this here and saved it with a better name, so we're ready with that part. I'm going to try to do this in real time. So the first thing we have to do is something called including, caps lock. Capital A. I'm using another version of this that I wrote here for reference. So this is including what's known as the Arduino libraries, and these are bits of code that are already written for you that allow you to access some of the basic functions of the Arduino more easily. And we're going to include a second library called Servo, which is going to give us the functions and capabilities for software control of the servos. Now the next thing we need to do is we're going to create some constants, some named constants. So we're going to use this define, and we're going to say input pin 1. Let's just say input 1 is going to be on pin 10. And then we're going to define our outputs to this is going to allow us to use these names, input 1, input 2, servo 1, 2, 3, instead of the pin numbers for the Arduino pins in our code below. And that will allow us to change these pin numbers very easily without having to go to 5 or 6 or 20 or 100 different places in the code to change these numbers. It's also allows us to keep things straight and avoid mistakes, bugs, because everywhere we want to refer to pin 10, if we use input 1, then we make sure that that's always the same. Okay, the next thing we're going to do is create the actual servo control things. So we're going to create servo 1, like so. And this is creating 4 different servo objects that we'll be able to manipulate and do things with in the code below. And that'll be the things that actually control the servos. And if you look over here to the right, this is one of the things that I'm doing for simplicity instead of efficiency. What we can do is create an array of servos, which is a collection of them. So here I've created 4 of these servo objects and put them into an array, a group called servos. And this will allow us to, if you look down here below, use an index number to address those arrays, and it starts with 0, not 1. And we'll see later on how that makes the code a little more efficient, efficiently written. Okay, now by default you get two code blocks, two functions down here, one called setup and one called loop. Now the setup function, as it says here, put your setup code here to run once. This is called or executed when the Arduino first powers on, and anything that's put inside the setup code is run once and allows you to get things set up. And then the loop function is called repeatedly forever once the setup is complete. And so basically what we're going to do is we're going to configure everything, set everything up in the setup function, and then in the loop function we're just going to loop through and repeatedly check the inputs and then change the outputs based on those inputs. And then we'll wait a little bit, and then we'll go back through the loop again, and we'll just stay in this loop function until the Arduino is either reset or turned off or whatever. All right, so the first thing we're going to do is we have to tell the Arduino that our input pins are in fact inputs, and we use the pin mode function for that, and we give it the pin number and we call it an input. Then we're going to do that 4 times, and once for each of the inputs. And this is the first place we see where I'm using these names, right? So it doesn't, I can change the pin number here, and I don't have to go in here and change it because it's gonna reference those names to figure out what pin number this should be. And the second thing we have to do is to connect our servo objects here to our output pins here, and we use the attach function to do that. The way we do this is we reference the object servo1 dot attach, and then the name of the pin that I defined up here. So this is basically telling this servo1 controller object that it should use the pin number 14. And again, we're going to do that 4 times. Once for each servo. And we're going to make sure that the right numbers. All right, now this is pretty much all the setup that we have to do. We've made sure that our input pins that our touch toggles are going to be connected to are defined as inputs, and we've told our 4 servo objects which pins to use as their outputs. And these are the pins that the servos will be connected to. Now we're going to go into the loop code. So the first thing we're going to do is we're going to read one of the input pins and get its value. So we're going to create a variable to store that input pin number, or pin values, we'll call it pin value. We're going to reuse that a couple of times here. So we're going to say pin value equals, we'll use the digital read function, and what this does is it'll come back with either a high or a low value, depending on what the electrical value is actually on the pin itself. Let me take a step back and talk about this line right here. You notice this line has 2 slashes, and then the text, the editor is making that text in gray. This is a comment. Whatever you put between the 2 slashes and the end of the line is for human reading. It is completely ignored by the Arduino and by the compiler. So this is entirely just comments for human readability. I highly recommend them. If you look at this version over here, I've made a lot of comments to try to make that very readable. This is really good because it helps you remember when you come back to this 6 months later. The comments are invaluable in figuring out what's going on. I'm going to add a comment here and say will be high or low. And high and low are defined names in the Arduino code that represent the voltage that's on the pin when you do a digital read. I think they're numerically equivalent to 1 or 0, but yeah. All right, now what we're going to do is use an if statement. We're going to say if pin value equals high, we're going to do whatever's inside of these braces. And let me show you another thing here. You notice here we used a single equal sign. This is an assignment. So this is assigning whatever comes over here from the digital read to this pin value variable. Whatever pin value used to be is thrown away. It now is assigned to be equal to the result of this digital read. If you use two equal signs together, that is an equality. That's what we're usually used to the equal sign meaning in the real world. And what this is saying, this will come back either true or false. Either pin value is equal to high or it's not. So this doesn't change the value of pin value. It compares it to whatever's on the other side of the double equal sign. So what we're going to say is if the pin value is high, then servo 1, we're going to use the right method or function that's defined for these servos. I'll show you a little bit about that in a minute. And we're going to set that to, we'll say 30. And this is going to be, I think this is actually the closed position. I need to check the definitions for the Berrett Hill. I'm pretty sure green is the high voltage, which means that's usually we consider green to be closed. It could be either way, actually. So we're just going to assume that a 30-degree rotation of the servo is the closed position for the turnout. And so that's what we want to do if the touch toggle comes back with a high, which is a green. And then we're going to say else. So whatever goes in here is going to happen if this is false. We'll drop down here to this else line and we'll say servo 1.write 120. We'll say that's thrown. Again, remember the stuff after the double slash is comments just for us to read. Code doesn't care about that. Now this is one of the things what you could do is do some more of these defines or something to make it easier to adjust these. But these would of course have to be adjusted to get the servo to position where you actually need it to be to move the points on the turnout. So we're just using 30 and 120 as kind of placeholder values for that. But you'd have to actually figure out what those are. And there are some ways that you can write this code differently to make it a little easier to change those as you're experimenting, and we'll talk about that. Now we need to do this 4 times, and so we're going to copy that 3 more times, and we're going to change each one of these. So this one we're going to check pin input 2, input 3, input 4, and again servo 2, servo 2. And this is one of those places where there are better ways to write this code to make sure that you don't make mistakes and you don't have to repeat yourself a bunch. I will show you those later. But now we've got input 1. If the pin value is high, do this. Input 2, if the pin value is higher, do this. Check input 3. Pin values, change servo 3. And input 4, change servo 4. Now we're going to call the delay function. And what this does is it basically puts the Arduino to sleep. It's not really going to sleep, but it's basically just going to twiddle its thumbs for however many milliseconds you put in here. So we're just going to wait 200 milliseconds. And then once that's complete, we're not going to do anything else. We've reached the end of the loop function. Reach the end of the loop function, so it'll come back up here and start all over again. And it will check each pin again and change the servo to whichever value it should be based on the input value. And it'll wait 200 milliseconds to check again. Now 200 milliseconds is 1/5 of a second, and it's about as long as you can wait without a human being able to notice that there's a delay. If you go much longer than that, if you go even to 250, you can begin to perceive that the thing's just not as responsive. You'll notice that little delay before it recognizes that you changed the tag and then and respond to it. So I like you could go faster. I mean, you could do this every 50 milliseconds if you want. It's just going to do a lot of unnecessary checks. So we'll go with 200 milliseconds. Okay, let's compile this code and see what happens. Notice up here in the top bar, you've got a check mark button here that's called verify, and you have an arrow button that's called upload. And you've got new and open and save. We're not going to use those. When we click the verify button, the Arduino program is going to compile this code, turn it into machine readable version, and it's going to check it for errors, which is the more important part. And then it's going to give us some messages down here in this black part below. So I'll pull that up, and let's see what we get, if we get any bugs. Be absolutely amazed if there are no bugs. I am absolutely amazed there are no bugs. What we do find out down here, as it tells you, is that the sketch takes 2,344 bytes, which is 7% of the storage space available on the Arduino that we've chosen. There's about 30,000 bytes available. And also the global variables, which are your servos, basically, use 59 bytes, or 2% of your dynamic memory. Now you got to make sure that you don't use up all of this space. If you get much more than about 75% of either of these numbers, you're going to start having problems with the code running on the Arduino. So you either need to make your code smaller or get a bigger Arduino. But obviously we're nowhere close to that right here. I need to show you one more thing that I had already set up. If you look under Tools, you find this board selection here, and you need to choose which of the many different Arduinos that you're actually programming for. They're all slightly different. They're different sizes. They have different amounts of memory, different capabilities. So you have to tell the Arduino system which board you're programming for. And so you can see here I've selected the Arduino Pro or Pro Mini, which is the one that I'm using. And if there is more than one version of that, which there is for the Arduino Pro, you have to choose which processor. I think this will default to the Arduino Uno and whatever, probably the 328P, but you can see there's 5 volt, 3 volt versions at different speeds. And there's a 328, which is the higher power processor, and 168, which is the lower power one. So you just choose the one that you purchased here, both here and here. You don't have to worry about port yet if you're just verifying. We'll get to those other things when we do the upload. Now, just for fun, let's see one of the most common mistakes that happens, which is you forgot to put a semicolon at the end of a line. This happens a lot. And we're going to do the verify again. And you can see we get an error. And what it'll say down here, you can see line 28, column 3, which is right here. It expected to have found a semicolon before the mention of this variable, this object, servo1. So it's saying, hey, there should have been, I did this, I looked at this, and then all of a sudden I found myself here, and I should have seen a semicolon. Well, that's the mistake that we make. So that's exactly what we expected to see. So we'll put the semicolon back in, and verify it, and we get da-da-da. Okay, let's talk about hooking this Arduino up to the computer. So this is an Arduino Uno, which is the classic Arduino. I'm not going to go into a whole lot of detail on the board itself. This is actually kind of the thing everybody thinks about when they say an Arduino, and it's kind of the base model, if you will. The thing I want to point out is that it's got a standard USB port on it. Now this is the older board, so this is you know, the old USB-B printer style connector. It's big. Some of the newer ones have the smaller micro USB connector, or they might even have a USB-C version. But anyway, there's a standard USB port already mounted on the board. You just take a USB cable, plug it into this end, plug it into your computer, and you're done. With the Arduino Pro Mini, it's this tiny little thing here, just for comparison. You can see that's a much smaller board. It doesn't have that. What it does have are these 6 pins here on the end, which are connectors for a serial adapter. Now the serial adapter, the one that I have, looks like this. Bought this from SparkFun, and it has a micro USB connector on one side, and it has this female pin header on this side that matches the male pins on the end of the Arduino Pro Mini. There's one thing you have to watch. If you look very closely, see if I can get this, you can see there's some text. Of course, I have it upside down. Right at the bottom, you can see there on the far left it says DTR, and it's really hard to see, but on the far right here it says GND for ground. And if you look on this side of this board, you can see it also says DTR on this side and GND on this side. And you got to make sure that you get those lined up correctly. So you can see if I put it this way, then they're backwards. DTR on the Pro Mini is over here. DTR on the adapter board is here. So we flip it over and plug them in this way. And I'm going to flip this whole thing over because you can see now that I've plugged it in, it's connected to my computer. Little red lights on, that means the board has power. It's getting power from the USB. But it's very important to make sure that you match the DTR end and the ground end between the board and the adapter to make sure that it's plugged in correctly. Otherwise, the serial port won't work, and I suppose it's possible you might fry the board. Can't make any promises. That's all you got to do at this point. The other end of the USB port's just plugged into any of the standard USB ports on your PC. Okay, let's upload the code. So we have our Arduino plugged into the USB port on the computer now, and if we look in the Tools menu, we can see that the port menu selection here has selected dev.cu.usb serial-AL010UL7. This is a Mac. The names are a little weird, but that is the USB port that that I physically plugged the Arduino into. On a PC, these ports are usually, they'll be something like COM1, COM2, COM3, something like that. But I can tell it is this because when I unplug the cable and then go back to the menu, you'll see, if we can get it to refresh, you can see that that port disappeared. It's not an option because I unplugged the cable. If I plug the cable back in, and again, give it a chance to refresh, you can see that came back. So that's how I know that's the correct port. So we've got the port selected, and if I look over here at the Arduino itself, I can see that the light's on. So this time we're going to click the upload button. Now the upload button is also going to run the verify, so you don't have to do these two steps separately. This will do both steps. So we're going to click that, and what it's going to do is it's going to again verify and and recompile the code as is after saving it. And then it's going to send it over the serial port to the Arduino and program the Arduino with the code. You can see here it says it's uploading, and it's done. It was very quick because it's a very, very small program. But you could see, let's do it again. We can see this turns yellow to tell it it's busy. You'll see we'll get our message about the storage space and memory usage. And it'll show here that it's uploading with a little busy bar over here, and then it'll tell us it's done. So let's watch that one more time. And done. Okay, well that was quick. And just for fun, let's send this one instead. Same thing. Maybe took just ever so slightly longer. So now that we've programmed the Arduino, we're ready to actually use it. So here's the payoff. We have the Arduino here, our control panel, and our servo. And when we touch the toggle, the servo turns. And that's that.